So the last thing we're going to cover with 45, 45, 90 triangles is how to actually come up with this relationship down here. So in order to do this, you need to understand two things. The first is the Pythagorean theorem, which you should be pretty familiar with. The second is the fact that radicals distribute over multiplication. So what that means is if you have the square root of two things multiplied together, you can take the square root of those two individual numbers and then multiply them together. So we're going to start with this, and then this will pop up once we start simplifying everything. So we want to get the same exact relationship that we have here. So we're going to label this triangle the same way that we've labeled this one. And recognize that this is a 45, 90 degree triangle. And we're going to say that this side is x. All right. Now, because it's a 45, 90, we know that this leg is also going to be x units long because those two sides are congruent to each other. Now, this side, the hypotenuse, we are trying to show that that is, in fact, x times the square root of 2. So what we're going to do is we are going to use the Pythagorean theorem as a starting point for this. So we're going to call this side A. We're going to call this side B. So one of our legs is A, one of our legs is B, and then the hypotenuse is going to be C. And we're going to start with the Pythagorean theorem. So the Pythagorean theorem says that if you take the square of one of the legs, add it to the square of the other leg, it should be always equal to the square of the hypotenuse in a right triangle. So now, A is equal to x, so I can write this as x squared. So I'm replacing A with x. B is also equal to x, so I can write that as x squared. And then c squared, that's what we're trying to figure out. We're going to leave that as c squared. Now, x squared and x squared are like terms, so I can add x squared to x squared, and I get 2x squared. Now we are almost there. My goal here is to figure out what c is, so I'm going to then take the square root of both sides. So on the left side, I'm left with the square root of 2x squared. And on the right side, the square root of c squared is just equal to c. And this is where the fact that radicals distribute over multiplication is going to come in. So we're going to think of the 2 as a and the x squared as b. So I can write this as the square root of 2 times the square root of x squared equals c. The square root of 2, I can't simplify. The square root of x squared becomes x. And now this says the square root of 2 times x. If I just change the order of that, I get x square roots, or x square root 2, which is the same relationship that we were given in the beginning. So you can remember that process of how to come up with it if you forget, or you can just remember the summary of that, which I think is a whole lot easier than this whole process, but I think it's important to know where it comes from.